So we are going to go ahead and do like a review for exam 2. I wanted to go ahead and show these negations right here real quick. If you have a statement with the form of all are, you would negate it with some are not. If the statement says none are, you negate it with some are. And then your some are gets negated with none are, which is basically this line. But if you notice, they got flipped, right? Because it's saying that it starts with some are, and it wants you to negate it. You would change that sentence using none are. And then lastly, if a sentence is in the form of a some are not statement, you negate it by saying all are. And I went ahead and wanted to show you this again. This comes from 3.1 because it's what we use on the review for like these 2 examples, okay? So it says, ow. Okay, so E2R, which is exam 2 review. The third problem on the review, which is on Canvas, and there is a key, says some women are presidents. So if you look at your negations, right here, we would be able to see that the statement is in the form of a some are statement. And so we would negate it with none are. But we're not going to say none women are presidents. We would just say no women are presidents. Okay, so that would actually be the answer to this third problem from our review. No women are presidents. Okay. I think that is just a little too good. Oh, I'm going to switch to my regular purple marker. Okay. Now for the fourth problem that is coming from our review, it says some pine trees are not green. So if I negated that statement, I would look at my form of statements. I have some pine trees are not. So this is some are not, right? So there's those words right there. And so what I would do in order to negate it is I would say all pine trees are green, okay? So all pine trees are green. To my knowledge, I'll try to say whatever problems are on the exam. I know for a fact there's one of these on the exam. Okay, so all pine trees are green. Okay, so we're done now with this little piece of paper, so I'm just going to go and move it, okay? For the problems 5 through 10, we used the simple P, Q, and R statements. I went ahead and wrote them down here so that we can do 2 problems from that little section. Our simple statement P was the coffee is Maxwell House. Our simple statement Q was the coffee is hot. And our simple statement R is the coffee is strong. The directions tell me to write sentences. So they're going to give it to me in symbolic form, and it wants me to change it into sentences. So I know that this is my if and only if, my bi-conditional statement, so I'm trying to not be so crooked. But it's not working no matter what I do. And then I have my P right here, and then it says not R. So I would start with my P statement, which is the coffee is Maxwell House. Y'all, if you see that the one-sided arrow, remember you start with the word if, right? So here we have the coffee is Maxwell House. And then that statement, that symbol, the way that we write it is if and only if. I'm going to go and write it out. But y'all, if on the test you saw that symbol and you did IFF, that's okay. That's the same thing. So if and only if. And it says not R. R is the coffee is strong. So we would just write the coffee is not strong because we're going to add that not for the negation. Okay. So that's how we would turn that symbolic form into sentence, like a sentence form. Okay, so for problem 10 off of the review, we have a whole lot of stuff going on. We actually have parentheses, we have multiple operations, and we have 2 negations. So the parentheses are going to come into play with where we place our comma, right? So wherever you have a comma in a sentence, you're going to have either 2 things paired together to the left of it or to the right of it, Okay, so just pay attention to your parentheses when you go into sentence form and pay attention to commas when you go into symbolic form. Okay, that's kind of how those relate to each other. So what we would do is we're going to go ahead and we're going to work right here. I notice that it says P or not Q. Our P is the coffee is Maxwell House, so I'm going to write that. I see the disjunction symbol, which is or. And then I see Q, but it's being negated. Q is the coffee is hot. That looks like the word not every time I look at it. Q is the coffee is hot. Because it's being negated, what we'll do is we'll actually say the coffee is not hot. So I have the coffee is Maxwell House or, thank you, the coffee is not hot. And then because this like ends my parentheses and I have more after my parentheses, what I do is I need to indicate that with a comma. This comma is what pairs this disjunction compound statement happening into parentheses. I have the conjunction symbol, which is the word and. Then I have my simple R statement being negated. So the coffee is strong will be negated and changed to the coffee is not strong. Okay, that makes sense? Yeah, awesome. So for problem 15, it's going to use the same P, Q, and R statements. This was actually the statements, I'm so sorry, not the statements, all of the different problems for 11 through 16. Okay, so the problem 15 says the coffee is strong and the coffee is hot, comma, or the coffee is not Maxwell House. It tells me to write it symbolically. I notice my comma, so I know for a fact I'm going to have parentheses. What's going to go inside of the parentheses is the coffee is strong and the coffee is hot. So I can do my conjunction symbol. To the left of it will be the statement that's to the left of the word and. So the coffee is strong is the simple statement. R. Good. I know I'm going to start with that parenthesis right there as well. We have and the coffee is hot. The coffee is hot is the simple statement. Q. And I did that because these were paired together with a logical connective on the left side of the parenthesis. On the right-hand side of the parenthesis, I have or, the coffee is not Maxwell House. So or is my disjunction symbol. The coffee is not Maxwell House would be the negation of my simple P statement. And so that would be how you would like change that into symbolic form. Okay, that makes sense? Okay. Now, what we're going to do is jump to problem 18 from the review. It says to construct a truth table on the test. If you construct a truth table, like if you need to, this has already been provided. And so what you do is you just work on each individual column. I'll show you kind of how I would grade problem 18 on the test, okay? So if I'm going to actually construct a truth table for Q, if and only if P or not Q, what I would do is I would go ahead and I just bring it down in its entirety in whatever column I have open next to all my different cases. And then I work individually on each thing. We are in math class, so we would definitely start within the parentheses. I notice that my Q is being negated, and so I would start there. The negation of Q is going to be the negation of whatever Q's truth value is in each case. So the first case, I have Q being true, so it's going to be negated right here to false, because that's what this symbol is telling me to do. It's saying to take the negation of my Q values. And then if you notice, there's like a pattern. It goes true, false, true, false. So the negation would be false, true, false, true. That's like the first line of work that I'm going to do. And then second, I would come over here, because I'm not done working within these parentheses. I have this simple statement, P. That's going to be the second little column that I work on. There's no negation symbol in front of it. So it's literally just saying that it's, the statement P, and it's just these values. I would go ahead and copy them down, because I'm going to need to have it kind of right here where I'm working to be able to take the disjunction of this first and second column that I've done. It will be the third and last column that I create within these parentheses, so it would be like the answer column of the parentheses, okay? Now I'm going to take the disjunction between this. When I have a disjunction symbol, I need to have either or of the values to be true. The only time I'm going to get a false with a disjunction is when they are both false. And so I ask myself, is this value or, right, the word or, is this value true? If you say yes, you assign that a truth value of true. Is this true? Or is this true? Yes. Is this or this true? Do you see here? That's the, I'm so sorry. I don't know if I said it incorrectly, but I definitely did have it written incorrectly. With or, the only time you get false is when they are both false. And so if you notice here, I have at least one T, I get a T. And then on this case right here, I have at least one truth value of true. So my outcome is true. And then here, is this or is this truth value true? No. Neither of them are true. That no equates to a capital F. Sorry about that. And then is this or this true? Yes. Okay, now I look, I've still got more things going on. That symbol obviously should, it should make sense to you that that's going to be the final answer column. In order to get to this final answer column, I need to go and copy down my Q column. Nothing has been negated, so I just write TF, TF. And now lastly, I can apply this biconditional operation with column 3 and column 4, because this is the answer column to my parentheses, and this is my Q. And so I'm asking myself, it's the if and only if, right? What you look for is doubles. If you have 2 T's or if you have 2 F's, your outcome, or what you end up getting as a truth value, is a T. TT gives you T, FF gives you T, doubles, right? Both being the same. And so this is where I'm looking. Right here, for this case 1, what I have is true, true. So I'm saying true, if and only if true, yes. They're doubles, I get a true. Here, case 2, these are not doubles, I get a false. Here, not doubles. Here, not doubles. So when my when my exam tells me to construct a truth table, you will already have the beginning setup, and this is what's required of you. Now, as far as your answer, if you number them, I would look, I know where to look, but I'm just saying for continuity, follow the process as much as you can. When you number them, that last column, the highest number, obviously that's when you finished your work, that's the answer column. If you were to do this, that makes that one column stand out a little bit. As far as me grading, you had to do this work and this work and this work and this work and this work to get to that final answer. So that's 1, 2, 3, 4, 5. This problem would be worth 5 points. That's where my points come from. So if you end up having a couple more symbols, or it's a PQR, you need a couple more columns, you get a couple more points. Okay? If it was something really simple like that, all you're doing is negating, bringing down your P, and then taking the disjunction, you would get 3 points. Okay, so that's kind of where all of that's going to come from on your exam. Okay, not highlighting it, it's not a big deal. For your constructed truth table, there's not an answer blank because this is where your work is done. Okay? Okay. So that's just going to kind of explain the exam. If you have a PQR on the exam, this is already given to you, and it looks very similar to this. There is horizontal lines that will separate each case. I just don't put them on my paper because I cannot draw a line to like save my life at all, ever. Okay, so let's do 21. What we're working on is P, then Q, and not R. If P, then Q, and not R. Okay, now let's actually do that. Okay, now I would start in my parentheses because we're in math class, and I would definitely start with this negation. This will be the first column I work on. After I do that, I would copy down my Q, and then I would apply this conjunction. Then I would copy down my P column, and then lastly I would do the conditional. And then this right here, this ends up being my answer column. Okay, so my not R means look at your R and negate all of these truth values. You should notice a pattern. It alternates between true and false, beginning with true. So if I negate that, I would actually alternate beginning with false. I want to try to keep them somewhat. Not having lines does not help me sometimes. Okay, second thing I would do is just go and copy your Q. Q goes in pairs of twos. TTFF, TTFF. There is not a negation in front of this Q. So you copy down TTFF, TTFF. Now, thirdly, I would take the conjunction of column 2 and column 1, the ones that I've numbered those. So, and. With our and operation, with our conjunction, you only get true when they are both true. T and T, only time you'll get T. So you just ask yourself, is this truth value and this truth value at the same time true? No. Is this and this true? Yes. This and this? No. If you notice, having a single F will result in an outcome of F, of false. Okay, now I notice that I finished this parenthesis, I look over and I have this P. I'm going to go ahead and just copy down my P. And now what I can do is the conditional between this, like the column that I've numbered 4 and the answer column that I've numbered 3. Okay, so with this biconditional, if you begin with T and you go to F, that is the only time you get false. T imply F equal F. So I need to look here. This would be where I said, hey, if you need to bring an extra pen, a highlighter or something, just kind of cover up the columns you're not using. Obviously, if it helps, do that. Okay, so as far as me writing, it's a little bit hard. I'm going to do this. Okay, if T, then F, I get F. This is always true. If it starts with true, it's true. If it starts with true, it's true. Oh, y'all see what I just did there? I was actually looking down thinking about a way to say something slightly different than I did in class, and I just broke math in 73 different places. Hold on, I'm caught on something. I'm not for sure if I have my whiteout. Hopefully I do. Do not. So I'm going to write over it with a different color. Here's where I am. T implies F is false. Only time I get false. Here, T implies T is true. Here, that was my mistake. T implies F. I'm just going to do this. is false. And then go down to the next case. T implies F. That's also false. Here. This is where I wanted to say what I was saying, but my brain got jumbled up. Do you notice how with the conditional, if you start at T and you go to F, you get F. So that implies that if you ever start at F, you'll always have true, because this is the only false. And I started to apply that to this, and I do apologize. Because I'm starting at F, and it's an implication, it's a conditional, I know for a fact that it will always result in a true. And so as far as my answer column is concerned, it would be that right there. Okay, that makes sense. Sorry for messing up. Okay, my brain gets ahead of my mouth sometimes. Okay, so determine the truth value. So problem 24 comes from the section on the review for problems 23 through 26. This is on Canvas. Okay, it says determine the truth value of this statement. If you are unsure of a truth value of a simple statement, you may use reference such as Google. So it's just saying they're going to talk about some holidays. If you're like, I actually have no idea when President's Day is, you just, hey Siri, and it'll tell you when President's Day is, right? So you can kind of see, is this a truth value of true, or does this have a truth value of false? Okay. So whenever I read this, what I see is President's Day is in February. That is true. President's Day was this Monday, and we are in February. So what I'm looking at right now is I'm looking at true, starting right here. Then do you notice how we have the comma? The comma means parentheses, right? And on the right-hand side of my parentheses, I'm making sure I wrote it down correctly whenever I did it. Yes. On the right-hand side of the parentheses, this is what gets paired together. On the right-hand side of the comma, this is what gets paired together in our parentheses. I see the word or, which would be my disjunction. And then because I'm on the right-hand side of parentheses and I've got more than one thing, I can open up my parenthesis. It says Memorial Day is in May. That is true. And Labor Day is in December. That's not true. I actually don't really know where Labor Day falls on the calendar, but I know it's not December, okay? And on the test, it's not anything that you really have to put too much thought in. It's very obvious, or I tell you like the different values, okay? But this right here, this is where I'm looking. This is how I determine the value of the statement. So I have a T, or work inside your parentheses, T and F. T and F. Is this value and this value at the same time true? No. So I get false. And I'm not done yet because there's still an operation. I've got one more line of work to do to get to my final answer to determine the truth value of the statement. If I'm talking about an or statement, I'm literally going to use the word or. Is this truth value or this truth value true? Are either of these true? Yes. Therefore, kind of like yes equals T and no equals F is usually how I try to explain it. Now, just to reiterate what I said earlier, on the test, if there's an answer blank and it's left blank, that implies to me that you didn't have an answer. So on 24, say we had this on the test, over here we would have this. In the directions, it'll tell you right, true, or false. So we would actually write true right here. Doing this does not give you points. Doing this gives you points, okay? So do all your work here, but give me your answer on the blanks. Okay, moving on. Okay, I really like these. I've said it before. They're supposed to kind of make it a lot simpler. Sometimes they can be confusing, but I hope they're not. This is a Pqr Truth Table, right? We have P, we have Q, we have R. We have 8 different cases and all of the work that it takes to solve it. So if I had you do all of this work, I could just say, tell me what the truth value is when P is false, Q is true, and R is true. And you would look and you'd say, oh, that outcome is true, right? But that's after having done all this whole work. If you're given a problem like this, it wants that one little specific value without having to do that whole table. Okay, that's why I like these. So you just have to pay attention. On the exam, just very similar to this, except for you'll have work to do your problems, there'll be directions. It'll say for problem 13, use this where P is this, Q is that, blah, 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 blah. Okay, make sure you read that, because if not, you can't really answer anything correctly. So determine the truth value when P is true, Q is false, and R is false. Okay, so what I do is I bring down all of the symbols and the operations. I'm changing the P's, the Q's, and the R's. Pay attention to the negations. If a negation is right next to a simple statement, you immediately go ahead and negate it. So here I have my open parenthesis, and then I have my simple statement P, where P is true. So I'm going to change that P to a capital T. Now bring down your symbol. Q is what? Q is false. Close. Bring down this symbol. Now let's change this according to what they told me. I would open. Right now, this negation is touching a simple statement. Go ahead and negate it now. Look at this. P is what? P is true. But within these parentheses, I need to negate it. So I'm not going to write a capital T. I'm going to write an F. Because this F is the negation of this true P. Do your symbol. My R is false. Now do this parenthesis, and then do the conditional. If I look at this left parenthesis right here, I have the biconditional arrow, which points both ways. I want them both to be the same value. They are not, therefore that results in a false. Bring down your symbol. Look in this parenthesis. I have F or F. Or, is this or this true? No. Now I've turned all of that into F implies F. If F, then F. With a conditional arrow, the only time I get false is TF. Every other time is true. And so you would write that in your answer blank. Okay? Work here, answer here. And it will actually, you don't have to create an answer blank. It'll already be on the test. I just didn't really put them on here. Does that make sense, y'all? Okay, let's do this one right here. I really like this one, like a lot, just because it's a little bit more complicated. Okay, so this negation is touching a simple statement, so I'm going to negate it right now. R, they gave me R as false, but when I negate it, it becomes true. Bring down your biconditional arrow. I see a bracket, I need to write it. I see a parenthesis, I need to write it. That's what allows you to keep up. It's technically the order of operations, because that's what we're doing. Here I have P or Q. Well, P's not being negated, it's just P, and P is true. Bring down your symbol. Q is false. Close your parenthesis. Bring down your symbol. Now I need to negate P's value. P is true, so the negation of P is false. Okay, now moving on. Can't really do anything right here to this. Probably be one of the last steps. Just kind of write it. I'm in math class. I work within the parentheses first. I'm going to open that bracket. I can actually do this operation now. I no longer need the parentheses. If you did it and you kept it, it's not really like a big deal, but you don't really need it. If I do T or T, is this or this true? Yes. Biconditional arrow, bring down your false. I'm going to go and close it with a bracket. Right? Now, these brackets are still like parentheses. You need to do that first. Okay? So I did right here first. I did the T or F first. Now, after I've done that, I still have some parentheses left. They're just in the form of brackets. So I have not touched this at all. You look inside of those brackets. T, if and only if F. Biconditional points both ways. I need them both to be the same. Those are not the same, so that results in a false outcome. And then again, look at this. T, if and only if F. That results in a false outcome. Answer blank, you would write the word false. Good? Okay. For the next chunk of problems that we do, I grabbed it from, I actually skipped no, I didn't skip anything there. I just want to make sure. It's for the problems 31 through 34. It tells you to just see if statements are equivalent. And so these are the two statements that I have that are equivalent. They're being divided by a comma. Okay, that's what tells me this is statement 1, and then this is statement 2. Get their truth tables, get the actual answer columns, and if their answer columns are the same, they are equivalent statements. Okay, and then you would just write yes or no in the answer blank. If you wanted to write equivalent, you can, that's fine. Okay, so I write my first statement down. That comma is where I'm going to put a vertical bar to separate and allow myself to have different columns to work on these statements. Y'all, second verse, same as the first. This is just like the problem 21 or 18. I don't remember what problems they were, but we're given a truth table, and this is the work that's needed right here. Solve this one, solve this one. Do they match? That's what you're looking for. Okay, so left statement, what I'm going to do is work within my parentheses. I'm going to negate my Q, copy my P, take their conjunction, and then negate. This right here, the last step of work that I do, that'll be the answer column. Over here, I'm going to negate my P, copy my Q, do their conjunction. This is my answer column. Do they match? That's what you're asking yourself. Okay, so I do the first step, which is negating Q. Q is TF, TF, so their negation is FT, FT. Step 2, it just says P, so I copy down P, not changing it at all. Step 3 is the conjunction of column 1 and column 2. This is and. Is this and this true at the same time? No. Is this and this true? Yes. No. No. Last column, I'm underneath the negation symbol, so I'm going to negate the third column. It's F, T, F, F, so it gets negated to T, F, T, T. Do not the same thing, because this is slightly different, but kind of solve this second statement, see if your answer columns match. The first thing I would do is negate my P. P is T, T, F, F, so the negation of P would be F, F, T, T. Q is just a copy of the original column. Lastly, take the conjunction of these two columns. This is saying and. Is this and this true? Sorry. Oh. I was trying to figure out, I was like, hold on, this wasn't the way that it was answered in my first class, but I actually think I selected different problems to do, just so that my first class would have more problems to look at than what we just did today in class. So the first class, they were equivalent, and now this is going to work out not to be. And that was my confusion. I thought I did something wrong. The conjunction. of F and T results in a F. I should instantly be able to tell that these are not equivalent, but because the exam is based off of your work per like columns and the like each individual thing, I would just go ahead and finish this out. Okay, is this and this true? No. Yes. No. And so in your answer blank, you could just write the word no. You don't have to write not equivalent. You could just write no. Now, as far as the test is concerned, we did 1, 2, 3, 4, 5, 6, 7 rows of work. So it is a 7-point problem. That makes sense? Okay. Now, we have 2 problems left to do, and that will be your exam to review. I also recommend doing, if not every single problem on the actual review, more from each chunk, each little section, right? We did, whatever, if I did 1 from here, then go ahead, I think I did 2 from here, maybe do another 1 or 2 of them. I did 1 from here, so maybe pick 2 of them. Okay, the ones that look the hardest to you, and then there's also a key that I typed up as well, and they're the key and the reviews on Canvas. Okay, and that's just so that you can get even more practice than what we do in class. So what I have here, I did kind of mess up a little bit, so I tried to add it very poorly. What we're going to do is we're going to actually write the converse, inverse, and contrapositive of the following. Okay, I'm gonna take a drink of that drink. And then I just have 2 different examples here. They're very similar to what's on the exam. And then I will actually tell y'all there's, 1 of these, 2 of these, 3 of these, okay? Okay. Bless you. So, my ability to write a converse, inverse, or contrapositive comes from a variation of our conditional statements, right? Our conditional statements are if P then Q. Right? I'm going to call this OG. That's like the original. That is the original conditional statement. It's if P then Q. Okay? Now, if I take the converse of a statement, you swap shoes with your friend. I think of shoes when I think of Converse, right? So you and your friend wear the same size shoes and you swap them. If I take the inverse, and y'all, I would write the whole word if that would confuse you later. I kind of try to smush it here and I don't have much room. If you take the inverse of a conditional statement, what you do is you actually swap the consequent and the antecedent. No, see, I did it right. And then I doubted myself. Whenever you take the inverse, you negate them. Converse, swap. Inverse, negate. So they stay in the same they stay in the same position. If P then Q. The only thing is it's if not P, then not Q. Goodness, let me take another drink. And then for the contrapositive, what you do is both of these steps. You will swap them and negate them. So it becomes if not Q, then not P. So the original is if P, then Q. Converse, swap them. Inverse, just negate them where they are. Contrapositive, swap them and negate them. Okay, so our original is if I study, then I pass. So the converse would be what? The converse would be swapping them. We begin with the word if, because this is my P statement, this is my Q statement, right? Right? Okay. That if then, that's why I use the conditional arrow. This is saying if I study, then I pass. So now I'm going to say if Q, which is if I pass, comma, then P, which would be I study. Okay, now the inverse. The inverse is where they stay in the same position that they're in, but they both become negated. So it's going to be very similar to if I study, then I pass. But because they're both negated, I'm going to add the word not. And you would actually say I do not. Okay. If I do not study, comma, then I do not pass. Okay, and then for a contrapositive, most complicated word, most syllables, you do the most work. You're going to swap them and negate them. Okay, so the contrapositive is very, very similar to the converse. Do you see how the P and the Q were swapped? You're going to write your converse, but now you're going to negate both of them. So it's if I do not pass, comma, then I do not study. Neither of these questions or like this work on this page came from the review. I kind of tried to match the exam by doing like specific examples. Okay. And this on the test, like the converse counts for 2 points, the inverse counts for 2, the contrapositive counts for 2, and you are having to write the sentences, but this would be a 6-point problem. That makes sense? Okay. Now this one, I've always liked these. If you haven't noticed, I like anything that has the ability to be confusing. Okay, because I mean it really does show though if you understand what's happening. We wrote up here, okay, my OG is just a simple statement, you know, implying another statement. If you apply the converse to it, it just means to swap it. That's all it means, just swap them. So the converse of not P, Q, swap their position. Leave them the exact same, however they are, like the way they look and if they have a negation, but switch their position. I would be saying if Q, then not P. Just swap them, right? Now inverse, when you think of an inverse, they stay where they are, but they become negated. So my P will stay where it is, my Q will stay where it is. Now look at them closer. If I negate a negation, right, this would be like saying that this statement is false. If I negated a false, it would become a true, right? So it's like a double negation becomes a true statement. And then here, this is not negated, but in the inverse form, I'm supposed to negate it. So it goes like that. That is me keeping them in their same position, but negating both of them. If I negate something already negated, it becomes non-negated. And then contrapositive is the most complicated work because you're going to swap them like so, and then also negate them. So first, let me think about swapping them. My Q would go first and my not P would be second. That's this. Now let's look at this. If I negate these, my Q would become negated and my negation on my P would kind of fall off. You're not writing sentences in this particular example, but it can be kind of confusing, negating a negation and keeping things straight. So this problem is also worth 6 points. Okay? Okay.